This one's pretty easy. You just use the classic F equals ma. And not that. So we have m is 4. And we have F in the first case is 5 newtons, so 5 equals 4a, and so a equals 5 divided by 4, which is 1.25. That's not too hard. And the direction is to the right, of course. For this one, the direction is going to be to the right because the bigger force is to the right. And so let's see. F equals ma. We have whatever F is times 4, equals 4 times A. F is what? 3 minus 2. Okay, so 3 to the right, 2 to the left. So 1 equals 4A, and A equals 1 over 4. Number 4. First of all, it's not possible for this box to be at rest on an inclined plane with no friction unless there's no gravity, which doesn't really make sense. But unless he means the box is just at rest for an instant, and then it starts sliding, because it's going to start sliding. In any case, free body diagram. So I googled ramp free body diagram, and there's credit for the website. Normal force pointing up away from the ramp, perpendicular to the ramp. Gravity points down, straight down. Part of gravity, you can split it up, goes this way. Part of gravity goes that way. There's no friction in this one, but if there were, it would point that way. And you could ignore these little letters. That says F parallel, as in parallel to the ramp, and that says F perpendicular, perpendicular to the ramp. And these are talking about the parts of gravity, which we all know gravity splits up into components like any other force. It's just a slightly stranger split up because the angle is actually, when you have the ramp, then gravity points this way. So the angle, you're usually given this angle. That's a theta. And the angle is going to be that angle. That is the same theta as that. Which is interesting because that means that the adjacent, here's the angle, the adjacent is cosine, but that's the y direction. People often mistakenly think that sine is always y and cosine is always x. And in this case, no, the angle is here, and so this is cosine, this is the adjacent, and it's y. And then that's x. That's the x part of gravity. The magnitude of the normal force. So normal force is pointing away from not all of gravity, just this part of gravity. So the normal force equals mg cosine theta. Done. And where that comes from, by the way, is if we say F net in the y direction, I'm not going to write it like that, y. The F net is normal, pointing upward. Oh, by the way, this kind of diagonal direction is upward in ramp problems because it makes the math work better. So this is downward. And so this is not, it's not negative y. In most problems you'll see this is negative y. Gravity is straight along the negative y direction, but in these ramp problems, we twist the axes, so this is positive y, this is negative y, this is positive x. All of it's twisted. Shifted. Rotated is the word. So y equals n plus, or minus really, mg cosine theta. And that equals 0 because it's at rest. No, wait. It's not going to move in the y direction anyway, no matter what it's doing sliding on the ramp. It's not going to go break through the ramp, so it's not moving in the y direction. So acceleration is 0 in the y direction. Simplest algebra ever. Done. N equals mg cosine theta.